So thank you for having us today, and I'm happy really to deliver these few slides to update you on our recent project on developing a smart archival assistant for conversational feature and linguistic abilities. So I'm happy also to be with Lamia and Wassila, who are also contributor to this project. And yeah, I want to say this opportunity to say also to Wassila, also who is freshly graduated from the University of Geneva, and she got her master degree recently. So congratulations. Well, this project is initiated thanks to the support of contributions from University of Geneva and the International Portal for Francophone Archival Science, and of course the support of ACA, the International Council for Archives, and the very important also support of Enterprise Trust AI project and leaders. For these few slides, we will try to talk about the motivation behind this project, main goals, and the problems behind, and what we want to try to set up as a difficulty and issues. After that, we will share with you technical design and implementation, and what is planned for validation, including the testing processes and also the preliminary results. So few steps are also to be planned for the following work, for future directions, and many, few conclusive ideas. So digital transformation is of course, behind a lot of facilities, but not only facilities. We can also note that we are facing real problems with digital contents and how preserve, maintain, and a good access, wide access, secure access, but also good management and wide sharing. This, of course, one of the basic issue behind related challenges and serious difficulties related to financial aspects. So as you can know, we cannot reach and acquire recent standards. ISO is really not very accessible training sessions, and very advanced and relevant training sessions are not for free. Technical issue, diverse formats, and the systems, the integration systems are not really very accessible to any of our professionals. So we need knowledge, technical knowledge and expertise. Added to that, we are also facing the complexity of the terminology, even in the same language. So certainly with across languages, also collaborations. And if you remember your experiences when you are initiating projects with IT and other profiles and professionals, we can of course, definitely confirm this difficulty. So first of all, we need to define terms, and this is not accessible, of course. Academic and professionals also are not able to reach innovative research. And I can report on recent experiences from our colleagues discussing recently the accessibility to new and innovative papers in very interesting conferences. So we need to pay for it, and access to those knowledge, and this knowledge is not really very accessible. So restricted access to also practices is not evident. So professionals are not invited, or they don't have opportunities over the world to share and see what is shareable as an experience. Social and cultural barriers are also very important to note here, because if we take a set of principles, or even for archival functions, we will see a variety of applications through the countries, and even for the same country, we will see and note the differences between provincial and federal applications. We can also consider all this and see in this context how we can try to contribute solving this problem. So for us, we try to focus on how to develop advanced conversational AI with multi-agent systems and generative AI for network interactions by automated multilingual processing. We also targeting a fast and accurate search within archives and archival resources, having the context and the importance of context-aware search. Contextual responses will be also very important to consider. For that, we will work on relevant answers grounded in archival knowledge through personalized user experiences that will really help reaching an open archive knowledge accessible by assistance, the assistant that will provide a wide range of user using a cross-collection knowledge discovery. We are based this work considering, of course, many domains. We can see here machine learning, data viz, natural language processing, and of course, all this will be definitely help us more integrating more facilities. For example, the knowledge representations added to data visualization will make the knowledge representation more attractive, offering a connected information with the semantic understanding, of course, of the data, archival data. Definitely, we will use the computational archival science for helping the processes of automating the collection and processing of archival data. It will also help a lot for transforming raw data and archival resources. I'm talking about archival resources and archival knowledge because we are targeting two main facilities. One is for assisting and providing knowledge for archival practices, functions, and another side would be dedicated to exploring the archival materials. To know more about the system and the technical design, I will be happy to give the floor to Wassila, who is around. I think you are muted.
Recording in progress.
Yeah.
Do you hear me?
Yes, with the echo.
Sorry. Is it okay? Okay, perfect. So I'm gonna present the technical design of our initial agent and explain how our system works behind the scenes. As you saw earlier in the presentation, our project responds to several challenges, the fast growth of digital records, the variety of formats, and the difficulty of understanding complex archival concepts. To address these challenges, we built an initial agent system that combines AI, knowledge engineering, and structured data. And here how it works. So we started by gathering the resources that archivists and learners use every day. This includes restricted documents such as professional standards, internal reports, and course materials. And in the other hand, we have other access documents such as dictionaries, glossaries, and public archival portals. All these information are stored in the data warehouse, which functions as the central memory of the system. The goal is to give Archival access to both expert knowledge and basic terminology. The second step is preparing the data. The system cleans and transforms the information so the AI can understand it. This step includes cleaning the content, standardizing formats, organizing and labeling information, so we can ensure overall quality. Good presentation preparation is essential. If the data is clean and well structured, the system can give clearer and more accurate answers. Then we have the core architecture of this Archival. When a user inserts a prompt, several components work together. First, the system uses an embedding model to understand the meaning of the question. Then it searches of the relevant information using a vector database to find similar text, and an RDF graph, knowledge graph to represent knowledge in structured way. We also use a dual path approach. If the question is simple, the AI can answer directly. If it is more complex, the system first retrieves contextual documents and then generates an answer based on them. This improves precision and ensures that the agent stays aligned with real archival standards. Everything is accessible through a web interface designed for different type of user, archivists, students, researchers, teachers, or even curious beginners. Users simply type a question. The system then returns a clear explanation, relevant context, and the source of the information. This transparency helps users trust the answer and understand where it comes from. And next we have the workflow, the practical workflow. So to guarantee consistent results, our workflow follows 6 steps. The first step is the user interaction. So the question is submitted. Then the query pre-processing. So the system cleans and analyzes the question. Then we have the hybrid retrieval. So the hybrid retrieval searches both on the vector database and the knowledge graph. Fourth, we have the LLM processing. So the model generates an answer using the retrieved content. And then we have the post-processing. So we refine the answer for clarity. And finally, we have the response delivery. So the user receives a complete and clear response. So this structure makes our initial agent reliable, clear, and easy to use. Then we had some preliminary results to validate our system. We have two cases. So our goal during this validation was simple. So to check whether Archival truly understands archival content and give correct, useful answers. So we tested the agent on two important type of resource. The first case study was the ISEA, so the International Council or Archives. For this part, we tested the system with the ISEA Online Resources Center, which includes toolkits, guides, standards, glossaries, manuals, dictionaries, and bibliographics. This data set allows us to build a fully functional proof of concept. In the interface you see in the slide, so the system can understand the question, retrieve the most relevant ISEA documents, and generate a clear answer based on verified standards. And the results were very positive. So we had a coherent response. The answers make sense and stay aligned with ISEA terminology. We had a high relevance, and the source was verified. It displays the exact document used to build the answer. We had also a second case study. It was the PIAF, so the portal International Archivistique Francophone. Here we worked on building a complete and clean data set to prepare our second agent, because PIAF is a large multilingual platform containing all stages of archival management cycle. So we have developed an advanced web scraping and pre-processing pipeline able to handle different formats of documents and metadata. The goal was to transform PIAF models into structured machine readable data set. So and the results are so far very encouraging. More than 90% coverage of educational materials, full traceability shown where each piece of information comes from, clean and structured data ready to be integrated into the next various version of Archival. So this gave us a strong foundation to extend the agent to training needs and multilingual learning paths. All these initial results show that our technical design is a solid base that Archival is already able to assist users with clean and contextual and trustworthy archival knowledge.
Thank you, Wassila. So a few words for the next step. So after this initial agent, we want to go through other data sets. So we will integrate in the coming weeks the PIAF data set. And with heterogeneous data, our ambition is to integrate the data sets from inter-pares scientific predictions, and including and terminology and dictionaries. And as you can see here, also another challenging data set would be the ISO information. And by ISO here, we are targeting the open information and open PDF documents from preview of standards, from ISO standards. So we still not have the magic power to offer ISO standards for free for all people. So, and we are targeting to expand, of course, the capabilities with adding the RDF knowledge representation, and we will work on how to improve the prompting and the prompting capability. And one of the intelligent agent will be dedicated and will be responsible for reformulating and enriching the user prompts. So these are coming challenging tasks. So implementation also for distributed intelligent agents with parallel processing and collaborative problem solving. And all will be possible with extended use cases. And we are lucky to have this opportunity to have the help and the support of many of our partners. So as you can see, this is not an easy task. We will continue working to combine this Gen AI with knowledge engineering. We will try to go through these possibilities with combining also advanced RAG and knowledge graphs. Very brief also information here to highlight again the importance of, this is my timer, that we are really lucky and happy to have the support of our partners from University of Geneva and from Enterprise AI with Luciana and Mohammed Abdul Majid, with also all the young people who contributed with the wonderful results, meaning Mariam Abloua with her work on PIAF dataset, and Aisha to Orubadi for the demo video, so that you can find it also in this references list. Here we are, so ready for having some question. Hope this was useful.
Thank you very much. Yes, we're running a bit behind, of course, naturally, but time for a question.
I can ask a quick question.
Sure, thank you.
Yeah, I was wondering if privacy and confidentiality of information was a concern in your work.
Yeah, thank you, Michelle. Yeah, that was one of the initial questions that we discussed with our colleague here, and honestly, that was not really one of the top of the issues, meaning that since we targeted the public information, published web contents, basically, and secondly, we worked on local stored data. So this is the double guarantee for this. But we are targeting other restricted information with the second phase of the project. That would be really a real challenging step.
Yeah, because I believe there are, in your design, there are large language models and servers that you're using that are online and information leak there. Thank you very much.
Thank you.
This is Richard. Just a quick question. Could you say a little something about your intended use and the underlying technologies you might be considering for using knowledge graphs in your RAG pipeline?
Yeah. Oh, well, this is maybe a question for Lamia, who is our expert on knowledge graph. And yeah, please.
Yeah, thank you. We have in the University of Geneva developing a platform for archiving and data preservations, and it's based on RDF, and it's it's our home platform we are going to use.
This is already developed.
Okay, thank you.
PDF, yes.
We can send the more information for